All right, so in the first section of notes, again, this is 6.6 is going to be notes 3. So it's the second set of notes that we have. And we're going to talk about perpendicular lines today. So we talked about parallel lines, and I actually have my piece of scrap paper here on the side where we talked about parallel lines and how they never intersect each other, and they have the same slope and they have different y-intercepts. Okay, so now let's think about perpendicular lines. And what does the word perpendicular mean? Well, perpendicular means that the lines are going to intersect. So let's quick draw this out. All right, so we have one line. It looks like this. All right, and we have our second line. Now, our second line intersects this line, but it's how they intersect that makes it special. All right, so they actually intersect in a 90-degree angle. So when they intersect each other, this must be a 90-degree angle. That's what the word perpendicular means. So again, perpendicular means it has to have that 90-degree angle. Now, based on this graph, what do you think the slopes are going to be? They can't be the same because parallel lines have the exact same slope. So they have to be some sort of different types of slopes. Well, there's the specific kind of slope they need to have, and that's what we're going to talk about and practice with today. So keep this in mind as we're kind of going through. And again, I'll have this off to the side here while we're going through. So perpendicular lines have, let me color code for you, have opposite, I'm going to choose reciprocal slopes. Okay, we don't care about the y-intercepts. The y-intercepts can be the same, they can be different, it doesn't matter. So what does opposite mean? Well, if one is positive, the other one should be negative. All right, or it has to be negative, I should say, not should be. And reciprocal, we saw that word when we talked about fractions. So let's say we have a fraction. Well, let's say it's a over b. If we want the reciprocal of this fraction, it means we flip the fraction. So it becomes b over a. All right, that's really important when it comes to looking at our slopes, okay, for our perpendicular lines. So question 1, very similar to the first question we talked about on the first set of notes with parallel lines. All right, we have to determine whether or not these two lines are perpendicular. All right, so in order to determine whether or not they're perpendicular, we need to know what their slopes are. Again, we don't care about their y-intercepts because their y-intercepts can be the same. It really doesn't matter, all right? It doesn't matter where they intersect on the graph. It matters how they intersect. And how they intersect is affected by their slope. So we only care about their slope, all right? So the slope of this first equation is 3 over 2. All right. Do we know the slope of the second equation, like as it's written? No, we have to do a little bit of work. We have to get y by itself. So draw your line. We're going to solve for y. So minus 4x on both sides. And we get 6y equals negative 4x plus 12. All right, y is not by itself yet, so I got to divide by 6 on both sides. Y equals negative 4 divided by 6 is negative 2 over 3 x. And then 12 divided by 6 is 2. Now I'm going to go through and pick out what my slope is. So my slope for this equation is negative 2/3. Okay. Now to answer the question, are these two equations perpendicular? And we need to explain it. If it's yes, we need to explain. If it's no, we need to explain. So let's look at our fractions. We have 3 over 2 and negative 2 over 3. First thing we want to look is one positive, one negative. This one's positive. This one's negative. So it works so far. Okay, it works for them being opposite slopes. Are they reciprocal slopes? So if I have a over b, is the other slope b over a? So we have 3 over 2 and then 2 over 3. So are they reciprocal slopes? Yes. So the answer to this question, yes. They are perpendicular. And that's a little fancy symbol to mark perpendicular. They are perpendicular because they have opposite reciprocal slopes. And that's our answer. Okay? So then, very similar to parallel lines, we're going to write an equation for a perpendicular line. So we're given a point, and we're given that we have to find a line that is perpendicular to this line. So when it was parallel, we took the same slope. The slope of this equation is 5. I don't want the same slope. I want the opposite reciprocal slope. So now, my perpendicular, I'm going to use my fancy little perpendicular symbol. My perpendicular slope would be, well, this is positive, so my slope has to be negative. If I made this a fraction, let me use pencil, hold on. If I made this a fraction, I now have to flip that fraction. So instead of 5 over 1, it becomes 1 over 5. Oops, that was my negative symbol. Whoops, there we go. Okay? So now my new slope is going to be negative 1/5. All right, so I took care of my slope. I need to use this point. So this is going to be my x1, y1. All right? I have a slope, I have a point. Guys, we're going to use point slope form. Here we go. Y minus y1 equals m times x minus x1. Substitute in. Oops. Y minus negative 2, so it's going to be y plus 2 equals m, which is not my old m, my new m, my perpendicular m. Negative 1/5, parentheses, x minus x1. Minus x1. What is x1? 0. Minus 0. Guys, does it matter if you write plus 0 versus minus 0? No, they're the same thing. Okay, so this becomes my equation. All right, and this equation is perpendicular to that equation because I found the perpendicular slope and used that point.